Welcome back. In connection with the previous lecture, that means in the previous lecture we have seen the syntax of the entity declaration, and also we have written the entity declaration for an half adder. Okay, so in the syntax we observed that entity name, signal names. So in the language, generally for giving the names we are using identifiers. Okay, the purpose of identifier is to name different units like entity, architecture, packages, etc. And another purpose is to name the signals, variables, constants, functions, procedures, etc. Okay, all these names in the language called identifiers. But for writing or giving the names, you need to follow certain rules. What are the rules? That you can see in the coming slide. Then with reference to mode, in the language there are 4 different types of modes: in, out, buffer. So I said already, the word in place of mode is used when the signal is input to the system. Similarly, the word out is used when the signal is output from the system. Suppose sometimes a signal is used as input to the system and also output from the system. In such cases, in place of mode, you need to write in out. Buffer means the action of buffer also same as in out, but it has only one source. Okay, then let us see what are the rules you need to follow for giving the names. Okay, so first of all, remember the language is not case sensitive. Okay, it is a case insensitive language. Okay, now coming to identifier. Identifier means a group of characters. So what are the different characters you can use in that group means it allows all the alphabetic letters A to Z. It may be, I said already, the language is not case sensitive. Therefore, if you use either a capital letter or a small letter, treats the same. Okay, it allows all the digits 0 to 9. But coming to special characters, only underscore you can use, only underscore. Then the identifier should start with the alphabetic letter only, not with the numeric or special character underscore, and may not end with the underscore. And 2 successive underscores you should not use, and you can't use reserved words or keywords as an identifiers. Reserved word means already while writing the entity for half adder, we have seen, or in the syntax itself, some words like entity, is, port, end, etc. words already used in the language. That's why they are treated as the reserved words. Also keywords, you should not use those words as a identifiers, right? So like that, these are the different rules you need to follow while giving the names for different units, okay, and different signals or variables, constants, etc. Okay, then coming to architecture body, the second type of design unit is architecture body. So you know the purpose of architecture body is it describes the internal action of the digital system, whereas the entity declaration describes or it declares only inputs and outputs, whereas the architecture body declares or defines the internal action. But in the language, okay, before going to see the modeling style of architecture, let us see the syntax of architecture. The syntax of architecture is, it starts with the word the architecture. Okay, it starts with the word architecture, then architecture name of entity name is. Okay, so architecture name is user defined name. Okay, user defined name, you can use any name, but usually the related name you have to use of entity name. So to which entity this architecture has to be related, so that information represented through this entity name followed by is. This is the first line of the architecture syntax. Then some declarations. After the word begin, after begin some statements, after that end the architecture part. That is, in the syntax of architecture you can see two different parts. One is the declarative part and another one is statement part. So these two are separated by the word begin. That means before the begin all the declarations can appear. So the different declarations you can do here, like type declarations, signal declarations, constant declarations, function declarations, procedures, component declarations, etc. declarations you can write before the begin. But after the word begin, all are the statements. All are the statements. Here in the architecture body, whatever the statements you have written are called concurrent statements. Concurrent statements, because all the statements executed simultaneously. That's why named as the concurrent statements. So then finally the architecture ended by the word end architecture name, then semicolon. Okay. So but in the language, the architecture modeling styles are 4 different types. Our architecture body you can develop in 4 different styles. They are data flow style, structural style, behavioral style, and mixed style. Mixed means, in the mixed style, if you use more than one above style, then it is called the mixed style. Okay. So first of all, coming to data flow style, let us take same half adder as an example. How to write program in the the appearance of program in the data flow style. Okay. In the data flow style, let us take same half adder having 2 inputs with the names A and B, 2 outputs with the name sum and carry. Let us see once again the syntax of this half adder. So entity name is half adder is, then port AB signals are inputs, that's why the mode is in here, then data type is standard logic. Okay. After that declare sum and carry, these 2 signals are outputs from this system of data type is same standard logic, then end entity name, then a semicolon. Then actually you have to use semicolon after half adder. After that the entity declaration. Okay. So as per syntax, architecture, it start with the word architecture with the word architecture, then architecture name of entity name. What is entity name? Half adder. Here entity name is half adder is. Okay. So here architecture name is DF, that means data flow style. So generally related meaning word you need to, or meaningful word you have to use as a names. Okay. So data flow. Then here no declarations in the data flow style generally. So that's why I directly write begin. After begin, the statements starts. In the data flow style, the type of statements are known as the signal assignment statements. Signal assignment statements. The appearance of signal assignment statement is like Boolean equation. Like Boolean equation. So let us see what is the Boolean equation for sum and for carry. What is the Boolean equation for sum? A XOR B. A XOR B, whereas for carry A and B. Okay. Now coming to signal assignment statement for sum is sum less than equal A XOR B. Okay. Similarly for carry less than equal A and B. A and B. Yes, here you have to write B. A and B. So appearance is like Boolean equations. Okay. So these two are the output signals with the assignment symbol less than equal. For signals the assignment symbol is less than equal. So sum and carry are the signals. How can you say these two are the signals? Because these two are declared in the entity. Okay. So whatever you declare in the entity part, they are treated as the signals. So for signals the assignment symbol is less than equal, then followed by A XOR B for sum, A and B for carry. Here XOR and AND are the operators. These are predefined operators in the language. Okay, so operator names also you should not use as a identifier. Okay, then finally end the architecture, and architecture name is DF. Okay, architecture name already we have given it as DF, so end with the architecture name. So like that you can write data flow style programs. Okay, then coming to another modeling style, that is structural. I would like to now write the program for the same half adder in the structural model. Okay, so let us see. So what architectural style in case of structural, how it would be. Okay, so similarly the syntax start with the word architecture, then architecture name. Here I am writing it as STR. Its meaning is structural style of architecture. Of entity name already given, half adder is. Then in the structural style of modeling, a minimum of one declaration is must. That is component declaration. That is called the component declaration. Okay, so in the structural model, so before writing the program you need to identify how many different types of components are available in the logic diagram. So coming to this half adder, here two components are there, two different types of components are there. One is XOR gate, named it as X1, and another one is AND gate, it is named as A1. Okay, so two different components are available, therefore two different component declarations you need to write in the declarative part of architecture. Okay, so you know in the architecture body two parts are there, both are separated by the word begin. So before the begin, now you have to write two component declarations, one declaration for XOR gate, another declaration for AND gate. Okay, now let us write the component declaration for XOR gate. So remember, the syntax of component declaration is similar to entity declaration, except there we are writing the word entity, but here we are writing the word component. Okay, so in later classes we can see the syntax of this component. Now for this example, let us see how to write the component declaration for XOR gate and AND gate. So here component XOR2, this is the component name, it is user defined name. Its meaning is the component is two input component, that is two input XOR gate it is. Next its port is, it has two inputs named as X comma Y. Two inputs are that's why the mode is in, then data type is standard logic, and one output. Okay, that XOR gate has two inputs and one output is Z out, data type is standard logic. Then end this by the name component. Okay, end component. Okay, similarly give the component declaration for AND gate. So same as previous one with the word component AND2. Its meaning is two input AND gate it is. Then its port is port of X comma Y, means it has two inputs. With one is X and another one is Y. Mode is in, followed by data type, that is standard logic. Next it has only one output, its name is Z. Mode is out, then data type is standard logic. Finally end component. So like that you have to declare two components, one for XOR gate and one for AND gate. Okay, so remember the syntax of component is similar to entity syntax. Okay, then the word begin. Okay, so after begin, here the statements are called instantaneous statements. Okay, instantaneous statements. These statements, let us see the syntax of these statements. Okay, the number of instantaneous statements are equal to the number of components in the digital circuit, the number of components in the logic circuit. Okay, here how many components are there? 2 components. Okay, so that's why 2 instantaneous are be present in this code. Okay, so after begin, let us see the instantiation statement for XOR gate. XOR gate, it start with the label name, that is the name of XOR gate here is X1. X1, that is called label name, colon, the name of the component. For this XOR gate, the component name is XOR2. XOR2 followed by it port map of, it is named as sensitivity list. It is not sensitivity, that is port map list. Port map list, that is what are the inputs for this XOR gate from the entity. By observing this diagram, this XOR gate inputs are, one is A and another one is B. So therefore you directly write down like A comma B. A comma B are the inputs, comma, and what is the output of XOR gate from this diagram? That is sum. Okay, sum, right, like that you have to write. Okay, but the order must be, whatever the order you are going to write in the port map should be in the declaration of the component. Okay, in the XOR component, X, Y, the first 2 declarations are the input and the third one is output. Similarly, the same order you need to follow in the port map. A is the input, B is the input, and sum is the output. Okay, so then coming to the instantiation statement for AND gate is, again start with the label name. Its label name is A1, then colon, component name for the AND gate is AND2, then port map of, its inputs are A, B, A comma B, and AND gate output is carry. Okay, so this is the instantiation statement for the AND gate. So finally end with the architecture name. Actually here architecture name is STR. ST, for that you have to write here, instead of DF you have to write the STR. Okay, so this is the structural style of modeling. This is known as the structural style of modeling. Okay, so in the structural style of modeling, one compulsory declaration is component declaration. The number of component declarations are equal to number of different components available in the logic diagram. And after begin, the statements are called instantiation statements. The number of instantiation statements are equal to the number of components in the logic diagram. The number of components in the logic diagram. Okay, so this is the structural style of modeling. Then coming to another style of modeling is behavioral style of modeling. So let us see directly the architecture body for this behavioral style of modeling, because already entity is available. We have written entity for the half adder. For the same half adder, now we are going to write behavioral style of modeling or behavioral style of architecture. Okay, so same with the, it start with the word architecture, then architecture name. Architecture name here is BEH. I am giving BEH, that is behavioral. Of entity name, that means half adder is. Okay, then begin. Here also no declarations, that's why directly I am using the word begin. So after begin, in the declarative, in the statement part, in the behavioral style of modeling, the type of concurrent statement is process. The type of concurrent statements you have to use is process. Okay, so we start with the word process. You can see later the syntax of process for each and every concurrent statement syntaxes you can see in later classes. Okay, so it start with the word process of sensitivity list. That means the execution of this process depends on what signals. Okay, so here since the half adder has 2 inputs A and B, So the output result depends on both the values A and B. That's why these two are represented as a sensitivity signals. Okay, A comma B. Then begin. So this is process begin, whereas this begin is architecture begin. As per syntax of process, it also has two parts. Both are separated by the word begin. Okay, the word begin. Then after begin, so in the process, the statements are sequentially executed statements. Here all the statements are called the sequential executed statements. One of the sequential executed statement I am taking here, that is if. So for writing the behavioral style of modeling, it is better to have the data of a logic circuit, that is truth table. If you have truth table data, you can easily write the program in the behavioral style of modeling. So let us see, this is the truth table for the half adder. In case of half adder, 2 input means 4 possibilities, 0 0 0 1 1 0 1 1. With 0 0 input, sum is 0, carry is 0. For 0 1 input, sum is 1, carry is 0. For 1 0 input, sum is 1, carry is 0. Whereas for 1 1, sum is 0, carry 1. Okay. So with this data, let us see how to write behavioral style of coding. Okay. So for that I am taking if statement. So if A equal to 0 and B equal to 0, then means if A input is 0, first input is 0 and B also 0. If both inputs are zeros, what would sum value? 0. What would carry? 0. Okay. So the signal assignment statements are sum less than equal to 0 colon carry less than equal to 0. So two signal assignment statements. One signal assignment statement for sum, another signal assignment statement is carry. Okay. Suppose if this condition is failed, means let A equal to 0, B not equal to 0. That is, suppose if you take the second combination, A equal to 0, B equal to 1. That means this condition is not satisfied. Okay. So that is represented through else part. So else if means this condition is failed, A equal to 0, B equal to 0 condition is failed. Now what is the condition? You need to check A equal to 0 and B equal to 1. If this it is satisfied, then do the sum is assigned with the value 1, whereas the carry is assigned with the value 0. Okay. Clear? Similarly, next coming to the another combination, that is third combination, A is 1, B is 0. That is else if A equal to 1 and B equal to 0, then sum is assigned with the value 1 and carry is assigned with the value 0. Okay. Let us see another combination, that is 1 1. Suppose if this condition also not satisfied, you need to go for else part. So else if A equal to 1 and B equal to 1, then sum is 0, carry is 1. Then finally end if. So like that the if statement is ended. Okay, this is called totally if else if end if statement. Okay. So this is one of the statement in the process. This is one of the statement in the process. Using this statement, you can write behavioral style of modeling. Then after that, so you have to end the architecture. You have to end the architecture. How can you end the architecture? With the word end followed by architecture name. Okay, what is the architecture name is? Name here is BEH. Okay, so finally write end BEH. Okay, here it is written as DF, but it is not DF, it is BEH, right? BEH. Okay, and BEH. So like that, the architecture body you can write different styles like data flow style, structural style, behavioral style, and also you can combine all these or any two. That model is called the mixed style. Okay, so generally what type of style you need to write means, that is based on the data availability. For example, if you see here, If the truth table data is only truth table data is available with reference to digital system, the preferable model is behavioral model. Suppose only the logic diagram is available, what type of style you can prefer? Yes, that is structural style. Okay. Suppose only Boolean equations are available for a digital circuit or a system, only Boolean equations are available. You don't know truth table and you don't know logic diagram. So in that case, what model you have to prefer? That is the data flow model. Okay, data flow model. So like that, you can write the architecture body in different styles like data flow style, structural style, behavioral style based on the data availability. Okay.